Hi everyone! Today we're going to give a tutorial on how you can customize your volcano plot in the Trovomics visualizer. We have a written version of this tutorial on our website. It's got more in-depth detail about volcano plots, so be sure to check that out there. Let's get started. I'm in the experiment dashboard and I'm going to select the demo dataset. When an analysis is complete, this Visualize button will appear. Let's click it to get into the visualizer. So the volcano plot is useful for seeing all your genes at once, and from here you can easily identify which ones are significant and also differentially expressed. In the Volcano tab, we see that we must select a comparison in order to visualize anything. There's a drop-down list of available comparisons, and these were specified by you when setting up your analysis. We've selected dilated cardiomyopathy versus non-failing. So now we have our generated plot. Before we get into plot elements, let's review global controls. Here you can turn on help icons, which will give you more information about what each setting is. You can also select what font you'd like in your plot. So let's get back to exploring the data. We have the main title here, Volcano plot, and a subtitle, which is the comparison you selected. On the right is a legend with all your groups and the number of genes within each group. And actually, if you click on a group, it will remove it from the plot. Clicking on it again will make it reappear. We can double-click on a group to only show that group, and double-clicking again will make all the other groups reappear. The x-axis represents the log2 fold change, and the y-axis represents the negative log 10 of the adjusted p-value. And of course we have the plot itself, which is a visual representation of our differential expression results. So on volcano plots, we tend to be most interested in the genes that are high up and farther away, so the ones in the outer quadrants. This is because the points on the outskirts represent higher fold changes in expression, and the points that are high have a smaller p-value and therefore more statistically significant. If we hover over a point, we see that it represents one gene. This gives us a lot of information. We can see the gene itself, the comparison we're looking at, the average gene count, the log2 fold change, the fold change itself, and the adjusted p-value in this case. This information can also be found in the data table below. We can zoom in on a selection of points. Make sure the zoom tool is selected before clicking and dragging a box around the points. Double-clicking will zoom back out. We can also select a subset of points using the lasso selection tool or the square selection tool. Once points are selected, only these points will show up in the data table below. We can also select a single point by clicking on it. And to deselect, you will need to click on either selection tool. So there's a lot we can do to customize this plot the way we want for a presentation or publication. Let's go down the controls in order. We can show significance by p-value or adjusted p-value. So right now we're looking at adjusted p-values, but if we click on p-value, we can see a slight change in the plot. So keep in mind, you might not see a drastic change. I can also change the p-value threshold or cutoff. So I'm going to make it bigger, which means more genes will be considered statistically significant. We see this in real time as the dashed horizontal line is moving down the y-axis. We can reduce the p-value cutoff so less genes pass significance. And we see the number of genes changing in each group in real time in the legend. Next, we can set the max y-axis value. In this case, we have it at 15. And it seems like this is pretty low, considering we have many genes above this max value, designated by the triangles at the top of our plot. So let's increase the axis value. 100 seems like it's too big. Let's lower it to 40. And now we have all points visible on our plot. The next thing we can change is the fold change cutoff. The default is 2, so upregulated genes need to be at least 2-fold higher, and downregulated genes need to be at least 2-fold lower. And this is represented by the vertical dashed lines on the x-axis at -1 and 1. So you see, as I'm increasing the cutoff, less genes are considered upregulated or downregulated. If we don't like what we've done or just want to start over, we can click Reset to set everything back to default. Once you like how the data is being represented, we also have some options for the aesthetics of the plot. These controls can be found by clicking on the paintbrush icon. We can adjust the size of points to make them bigger or smaller. We can also change the color of each group. So let's make upregulated genes a light pink. And for the downregulated genes, let's go with this dark green. And I'm going to make the not significant and normal genes a lighter gray. I can also edit the plot title and adjust the font size. For this tutorial, I'm going to delete the title. Under Plot Layout, I can adjust the height and the width of the plot. Adjusting the height will not affect the Y-max axis you set earlier. So once you have a volcano plot that you are happy with, you can download it by clicking on this download icon, and you can choose what file format you want. You can also adjust the pixel size. We can also download the plot methods and data, and this is found in all downloads. The methods will tell you exactly how the plot was generated, so it will tell you the colors you picked, the comparison you selected, and other customizations. The data will be the same as the data table below the plot, but in a CSV file. So with all these files, you can keep track of what each plot is showing. We hope you discover something new about your data, and of course, the Trovomics team is always here to help. Every paid subscription plan includes Trovomics consultation hours, where you get one-on-one time with one of our computational biologists to go over any part of the Trovomics process. Thanks for watching.